Welcome to question 9, which is the last question in this exam, and it is all about geometric series. So let's just outline a few things before we start. First, let's say the sum to infinity. The sum to infinity, you see there, is equal to a over 1 minus r, where a is going to be the first term, and r, so a red r is going to be the what's known as the common ratio, which is, well, you'll see what it is in a minute. So what else do we need to know? Well, we've got the sum to infinity, the nth term of a geometrical series is equal to a times by r to the power of n minus 1. So if we're looking for the fifth term, then it is the first term times by r to the power of 4. 5 minus 1, 4. So with that in mind, let's get started on question A. Find the sum to infinity. Isn't it convenient that I wrote that down there? So what do we have? Well, the first term is 12. The common ratio is 3 over 8. So let's do the sum to infinity. The sum to infinity is going to be 12 over 1 minus 3 over 8. And you can do that in your calculator, or you can do it on paper, however you like. It's going to be 12 over 5 over 8, which is equal to 12 times by 8 over 5, which is going to be equal to 96 over 5, which is equal to 19.2. So you can write down either of those. Both are correct. So next question. Show that the sixth term in the series can be written in this strange form that we see before us there. So the sixth term, let's go down. The sixth term is going to be, let's draw a line under that. Sixth term is going to be, let's not write a 6 there, let's have n of 6. Sixth term is going to be a times by r to the power of 6 minus 1. So let's go for red. What is that going to be? Well, we're going to have 12 times by 3 over 8 all to the power of 5. So what can we do with that? Well, we can start off by bringing this 5 inside here and simplifying these slightly. So we get 12 times by 3 to the 5 over 8 to the 5. Now, if we go back up to the question, we will see that they want everything in powers of 2 and powers of 3. So 3 to the power of something and 2 to the power of something. So let's split up our 12 and split up our 8 so that we can have 12. Well, 12 is equal to 3 times by 2 to the power of 2. So we get something in a 3 and something in a 2. And then we'll times that by 3 to the 5. Well, that's fine. Leave that as it is. And then 8. Well, 8 is 2 cubed. So if we make that 2 cubed, then what we're going to get is, so 8 to the 5 is going to be 2 cubed to the power of 5, which is going to be 2 to the power of 15. So let's write that in. 2 to the power of 15. And then what we can do after that is put this 3 together with this one and bring this 2 down here. So 3 to the 5 plus another 3, so we're going to get 3 to the 6 on the top, 3 to the 6 over, so we have 2 to the power of 2 on the top and 15 on the bottom. So what we're going to get is 15 minus 2, we're going to get 2 to the 13. And just like magic, we have got what we were aiming for. Excellent. So let's make some space, I think, and then get ourselves stuck into question C. Alright, good. I have some space to work with. Question C asks us, for 1 mark, write down the expression for u of n in terms of n, which sounds very wordy, but you know it's 1 mark, you know it's going to be something quite simple. So what you can write down is u of n is equal to, well, the nth term, we just did that, it is a times r to the n minus 1. A times r to the n minus 1. That is the nth term. So just write in what we know. 12 times by 3 over 8 in brackets to n minus 1. That's all you have to write down. That's it. Nothing more. So the next one. This is probably, I think, the hardest question in the exam. It's very long-winded, it relies on you being absolutely perfect with every step you make, and it is designed for you to make a mistake, just a little arithmetic error, because the maths involved isn't actually so difficult, it's just a bit of log kind of manoeuvring. So let's start us off then. So hence show, so use what we just did, which I just got rid of. Let's use that to show that this equals this. So what did we just have? Well, we just had u of n is equal to 12 times by 3 over 8 to the power of n minus 1. So what we are going to do first to try and get it like that is log both sides. So we get the log of u of n is going to be equal to, don't worry about this a at the moment, we'll come back to the a down there, this little a base, don't worry about that for now, we'll come back to it later, you just act like it's not there for now. So we're going to get log of 12 times by the log of 3/8 to the power of n minus 1. Now I'm going to go through a lot of steps here, so I hope you can follow what I'm doing. So what I'm going to do first is bring the n minus 1 here in front of there, and I'm going to split 12 into, just like we did before, into 3 times 2 squared, and I'm going to split it up then. I'm going to split it up. So leave the left hand side as it is. So log of u of n is going to be equal to log of 3 plus, I hope I don't run out of space here, log of 3 plus log of 2 to the power of 2, because when we do our log laws, if you have, let me go up here actually, we have log of a times b, that is exactly the same as log of a plus log of b. So that's that rule there, sorted out. So then what we can do in the next step is bring that 2 round here, but never mind that for now. Let's bring the n minus 1 in front of our log of 3 over 8, so plus n minus 1 log 3 over 8. So then, the next thing I can do, I can bring that 2 that I just mentioned, I can bring that round the front, and what I can do is split up this log 3 over 8. I can split that into log of 3 minus the log of 8. So let's do that. Let's go log of u of n, stays the same, is equal to the log of 3 plus 2 times the log of 2 plus, now here we go, plus n minus 1, be very careful not to slip up here, times by the log of 3 minus the log of 8. And I'm going to write 8 as 2 cubed here. Write that like that. So hopefully you can see what I'm about to do is bring this around the front as well once I've dealt with the n minus 1, because that is going to get a little bit hairy. So let's deal with that n minus 1. So for now I'm not going to bother writing this anymore because it doesn't change until the very last step. So I'm going to bring this equals around here to give me a bit more space. So equals log of 3 plus 2 log of, that says log of 2 plus, now here we go, I'm going to use a different colour here, n times by log 3 minus n log 2 cubed, so that's the n gotten rid of, then minus, actually I'm going to use another different colour, minus log 3, then plus log of 2 cubed. I hope you can see that in the video. So let's try and group some things together. We are going to now bring this 3 around the front, bring that round to the front there. So let's do it. Let's pick orange to do that. So we're going to be equal to the log of 3 plus 2 times the log of 2 plus n log 3 minus 3n log 2 minus log 3 plus 3 times the log of 2. See, it's getting very long and you have to be very thorough and actually take your time with it because it is designed for you to make a mistake. So what can we do now with this? Well, we have a plus log 3 and a minus log 3, so we can cancel those out, and then we can group together some of the rest of our terms. So let's underline our log 2's. That's a log 2, and that's a log 2, and that's a log 2. And then in purple, let's underline our log 3. So we've got an n log 3 there. And that's it, actually. Good. So let's go for black. Right. So we have, let's write down n log 3 first. N log of 3 plus 2 log 2 minus 3n log 2 plus 3 log 2. So that's going to be 5 minus 3n log 2. 5 minus 3n log 2. So that is pretty much as simple as we're going to get that. So let's check the form that they want it. They want us, we've got n log 3, which we have, and then they have it the other way around. They have minus 3n minus 5 of log 2, which is the same as what we've got, but we've just written it out without so many minuses in it, which, you know, we're perfectly allowed, we're allowed to do. Actually, you know what, I'm going to bring that, remember I got rid of this log of un, bring that back. So log of un is then going to be equal to n of log 3, and then what was it, minus, yes I think so, minus 3n minus 5 amounts of log 2. And then I told you we would come back to the little a they want down there. The base of the log is a for all of these, and we just put that in there to make sure that we know that the log is consistent for all of them, because you could have any number down there. You could have a 10 or a 20 or a minus 50. or anything in there. And if you have different ones, then it means all these terms are equal to different things. So if you put an A in there, it just means it's the same thing. Whatever it is, it's the same thing. You can try it in your calculator, but I don't think you will, because it's the end of the exam. But if you stuck with me until now, well done. I'll see you on the next exam.